So let's go ahead and look at a couple more things in the book, and then we're going to make use of those things that you were supposed to have memorized. Remember your trigonometric functions and the special right triangles. So on Monday, or I guess for you Tuesday, when I see you again, we'll have a little quiz to make sure you just memorized. All right? So if you haven't done that yet, you've got a week, basically, to get it done. Okay? And then after today, you should be able to do all of the 4-1 homework. So get a head start on that. Get that done, too. So you're not too far behind when we come back. All right, so I want to look on we're working on page 356 and 357, and there are just a couple of things I want to touch base with you on. So one of them is, up at the top is our compass, and this is not a big deal, but it's one of those things that you really need to know so that you can do some problems that are coming up. So here's your compass, right? Northeast, southwest. We measure from due north. That part we've already talked about. If I were to draw this line in right there that is exactly halfway between north and east, what do you think that label would be?
45.
Well, the angle would be 45, but the label would be northeast, right? Now, what you may or may not have known is that these 45s can be split in half, and this label that's on the north side of the northeast line, see, here's my northeast line. When I split this, I've done it on the north side, and here I've done it on the east side. So when I do it on the north side, this line is called north-northeast.
Yeah.
It's the north side of northeast. And this one is called east-northeast. It's on the east side of northeast. So you're familiar with that? You can do that in all of the quadrants. So if I split this one, that would of course be southeast, right? And this would be southeast, right? Okay. And all of these little angles, as I start splitting all that up, remember you said this was a 45, right? So when I split that, this one would be half of 45, or 22 and a half. So you could find the angle measure for any direction that they gave you, right? Knowing those divisions. All right, the other thing, or there's two more things I'm going to talk about. One is a problem like number 45. And I'm not going to spend a ton of time on it because you have already done these problems over and over and over again in chemistry class. It may not have been a bicycle wheel, but the idea here is we know it's moving at a speed of 45 feet per second, and we want to figure out how many revolutions per minute that is, RPMs. So in other words, we want to get from 1 unit feet per second to another unit revolutions per minute, right? And you know how to do that. You've done it a million times. I don't know how they start in chemistry. I usually start with the given. So I have 44 feet in 1 second, 44 feet in 1 second, 44 feet per second. And then I know that eventually, through a series of multiplications, however many it takes, I'm going to end up with revolutions per minute, right? So I'm going to have to start multiplying by something to get from one to the other. Now the easiest for me is I've got seconds, I need minutes. I can do that, right? I'm going to multiply by 60 seconds in 1 minute. Now, does everybody understand why I didn't do 1 minute over 60 seconds? That would be okay too, but why won't it work? I need those to cancel. Because I want to be left with minutes in my denominator, right? That's chemistry, or what you do in chemistry. Now, I've got my minutes, I'm all good there. but somehow I have to get from feet to revolutions. Now I want you to think about this for a second. This is a bike tire. How big is the bike tire? 13-inch radius. Okay, so let's pretend you have a brand new blacktop driveway. You take a big blob of white paint and put it on that tire and roll it down the driveway. What's going to happen? Well, you're going to have dots of white paint, aren't you? Every time, what happens? Every time the wheel goes around. So won't this be one revolution right here? And this is another revolution, right? Now, how far are those? What would those distances be? In terms of the wheel, what does a revolution represent? Circumference. Isn't a revolution simply a circumference? And how do I find the circumference of a wheel? 2 pi r. R is 13, so my circumference is 26 pi inches. So 1 revolution is 26 pi inches. Would you agree with that? Now I got my revolutions where I want it, and I got my minutes where I want it. I got to get rid of everything else. Well, the only thing left is feet and inches. Can I make feet and inches cancel out? 12 inches is 1 foot. So the feet are gone, the inches are gone, and lo and behold, all we have to do now is put it in our calculator. Be careful, as I told you over and over and over again. Let me do my numerator first. So it's 44 times 60 times 12. Okay, so there's my numerator. What's in the denominator? 2 numbers, 26 pi. And anytime you're dividing by more than one thing, you need to make sure you put it in parentheses. So we are making about 387.85 revolutions per minute. You're using the pi button on your calculator, which is right over to the side there. Okay, got that? Now there's one problem in this section that's hard. I don't think we did it yet. Did we do number 37? We did? Yes. The track problem? Good. Yeah, we did that? Super, I didn't see it on your notes. Okay. Had we already done this one? Yes. Oh my Lord. Somebody didn't take perfect notes or else I read them wrong. All right, so all this was redundant. Super great. Sorry about that. Okay, you can do this homework now. You're all good. You can do it. What we need to do now is talk about some of the stuff that's on that sheet. Because now I'm going to take your calculators away, and I'm going to ask you to find the sine of 60 degrees. Okay? Now, there's a process to this. Once you've done it for as long as I have, some of these you'll just have memorized. But there's a process where you can find any function, sine, cosine, secant, cotangent, whatever, of any of the special angles. And what I mean by the special angles are the angles that are in what kinds of triangles? 30, 60, 90 triangles and 45, 45, 90 triangles. So here's how we do it. We set up our coordinate axis system and we draw a 60-degree angle. So here it is. There's a 60-degree angle. Now, everybody's starting here, right? Because this is where angles start. So a 60-degree angle looks just like this. Once you get the angle drawn, I want you to drop a perpendicular to the x-axis. Now we're going to be drawing angles in various quadrants. Every time you draw a perpendicular, and you're going to do one every time, you're going to draw a perpendicular every time. Every time you do it, it's going to the x-axis. Okay? Now, that's a 60, that's a 90, so this guy up here must be a 30. Now I can label the sides of my triangle. What would the sides of my triangle be? Across from the 30 is a 1. Across from the 60 is root 3. And the hypotenuse is 2. Now, boys and girls, that's got to be memorized. Don't tell me you don't understand. Don't expect to pass a single thing from here on out if you don't have that memorized, because you won't. It comes up over and over and over again. You've got to know across from the 30 is 1, across from the 60 is root 3, across from the 90 is 2. Now, that's a right triangle, isn't it? And I know that in right triangles, I can use something called SOHCAHTOA. Chief SOHCAHTOA, chief of the trigonometry tribe. In order to use SOHCAHTOA, see that H right there? What's that stand for? Hypotenuse. So we're not going to be using SOHCAHTOA unless our triangle is a right triangle. Now, not all triangles in the world are right triangles, so we won't be using SOHCAHTOA always. But as long as you've got a perpendicular, you can use it. So what's sine by definition? Sine is opposite over hypotenuse. Now take a look at your triangle. I know there's lots of angles in there, 3 to be exact, but you're always keying in on the one at the origin. So with regard to this angle, which side is opposite and which side is hypotenuse? Opposite is root 3, and hypotenuse is, of course, 2. So the exact sine of 60 is root 3 over 2. Well, that's not so bad. Let me step it up a notch.
It's hard.
How about the tangent? Let's find the tangent of 150 degrees. All right, now we're going to go through exactly the same set of steps. So here we go. I'm going to draw. First of all, I'm going to draw 150. So I'm going to start here. Right? This is where I start. Here we go. Here we go. Would you agree that's about 150? Now, once I got my angle drawn over here, once I got my 60 drawn, what was my very next step? I created a triangle by dropping a perpendicular to the x-axis. And what did I tell you about your perpendiculars? They're always going to the x-axis. If you want to see me really wig out, draw a perpendicular this way. It's not pretty. Now, the 150 is not even part of the triangle. And that's okay. You have to figure out the angles of the triangle.
30.
So this angle right here is 30. There's no mystery there. Look at it. How do we know that's got to be 30? Because the straight line is 180, right? And you've already done 150 of it, then this part must be 30, which means this guy is 60. Now we can label our sides. Across from the 30 is 1, across from the 60 is root 3, and across from the 90 is 2. Now here's a new piece. See that root 3 right there? It's actually negative. Why is that root 3 negative? Because this is basically an x value. See how it's on the x-axis? This is an x value, and over here, x values are negative. Now this is basically a y value. Should that be a positive one? Yes, because going up is positive. Do you understand why both of these numbers were positive? We went over and up. Right and up are positive. The hypotenuse will always be positive. Your hypotenuse will never be negative. X and Y can be positive or negative depending on which quadrant you're in. Hypotenuse will always be positive. All right, so I'm ready to answer the question. What's tangent by definition? Tangent is? Opposite over adjacent. So here's your angle, remember, right here. So what would opposite over adjacent be? 1 over negative root 3. That's opposite, that's adjacent. So negative root 3 over 3 if you multiply top and bottom to rationalize it. The exact tangent of 150 degrees. All right, let me just take it up another notch. All right, now what's a little bit different about this one? It's in radians. Okay, now, all is not lost. Do you know how to change that to degrees?
180.
Okay, and it doesn't take very long, right? We can do that quite readily. How many degrees is pi? 180. Divided by 3 would be 60. Times 4 would be 240. So we're really finding the cosine of 240 degrees. Pi over 3 is 60, and 60 times 4 is 240. All right, so what do? We draw. 240 would be all the way over here, right? 240 degrees. How I drew it, or where it came from to start with?
Just where you got the 240 from.
Okay, pi is 180, divided by 3 is 60, times 4. It's 4/3 of 180.
Okay.
Now, what do I do next?
Perpendicular.
Oh, not yet. First I gotta make a triangle. So I'm gonna make a triangle by taking a perpendicular straight to the x-axis. We have drawn a triangle in 3 quadrants. I want you to look at these triangles. I call it the butterfly bow tie. Every triangle you draw will be a piece of the butterfly bow tie. Every time. You will draw one of those triangles for every problem. Okay, so having drawn the triangle, now I need to figure out my angles.
60.
This is 60. Now again, there is nothing magical about that. Use your common sense. You know this is 180. You know that's 240, right? So in between them must be 60. This is 30. So what are the sides? Well, this side would be 1. This side would be root 3, and the hypotenuse is 2.
So they're not negatives?
Well, now wait a minute. I'm sitting down there in quadrant 3. So what should be negative? The 1 and the root 3 are both negative because we went left and down. The hypotenuse is never negative. The hypotenuse is actually the radius of the circle. If you drew that on a circle, it would be the radius of the circle, so it will never be negative. X and Y can be negative. Now we want the cosine. So cosine is adjacent over hypotenuse. So that would be what? -1 over 2. So the exact cosine is -1 over 2. Okay, let's step it up one more. What if we have to find the cosecant of 5 pi over 4? CSC, that's your abbreviation for cosecant, CSC. Alright, so here we go, thought process. First of all, 5 pi over 4. Alright, so let's change that into degrees. We don't like that 5 pi over 4 thing. So we know pi is 180. A fourth of 180 is 45. And 5 45s is 225. So we're finding the cosecant of 225 degrees. So a fourth of 180 times 5. All right, so let's draw 225. Where's it? 225. Right here? Here's my perpendicular. I'm in quadrant 3 again. Now I need to label my angles so that I can label my sides. So tell me about the angles. This one, the important one, which is the one right here, that's the important one. In fact, it's called the reference angle. This is called the reference angle. It's really important. It's 45. Which means this one's also 45?
Yeah.
So what are the sides of my triangle this time? 1, 1, root 2. And both of the ones need to be negative because I'm in quadrant 3. Okay, now I've got a confession for you. I'm 57 years old and I teach math. I teach trigonometry. And I don't have the cosecant memorized. You know what I have memorized? Cosecant is the reciprocal of sine. And because I know what sine is, cosecant is going to be its reciprocal. So if sine is opposite over hypotenuse, then cosecant must be hypotenuse over opposite. So what will hypotenuse over opposite be?
Root 2 over -1.
Root 2 over -1 or negative root 2. Now, let me show you another little thing here to maybe keep in mind. You have sine, cosine, and tangent. The reciprocals are cosecant, secant, and cotangent. Notice how there are 3 functions without cos, and there are 3 functions with cos, and none of them are paired up. So the reciprocal of sine must be cosecant, because none of the cos are paired up. So cosine is paired with plain secant, and then tan and cotangent are paired in terms of reciprocal relationships.
Do we have those buttons on that calculator?
No. You paid $100 for that dumb thing, and all it's got are the big 3. We're going to talk about how we do that on the calculator after a while, not right now. Some people think this is a cosecant. It is not. Oh my land. Do not ever think that's the cosecant. That's the inverse sine. That's something totally different. Alright? Okay, one more. I'm going to make it as big and bad as I possibly can.
No.
That was a cosecant. Alright, let's do the cotangent of 11 pi over 3. The cotangent of 11 pi over 3. Alright, 11 pi over 3. Alright, how many degrees is that? Well, I don't know, it's going to be a lot. Because what's pi over 3? 60 times 11 would be 660 degrees. What does 660 look like? It's more than once around. So if you were drawing it, you would go all the way around. That would be 360, and then you'd have to go 300 degrees more, which would put you like over to here.
Oh my.
Remember, positive angles, we go up. Positive angles, we go up. All right.
60 degrees.
So I'm going to drop that perpendicular, part of my butterfly bow tie that I erased.
60 in the top left.
And I got to figure out how big this guy is right here.
60.
Now, you got to keep track. 60, you're right. You got to keep track of what's going on. You went all the way around and then 300 more, right? So basically, I didn't need to draw that extra loop. I just need to draw the 600 or the 300 part. And if this is 300, then there must be 60 left to complete the revolution. So this is the 1, this is the root 3, this is the 2. Is anything negative? The root 3 is negative. You are in quadrant 4, and y is negative in quadrant 4. Now I want the cotangent. I don't have it memorized, but I tangent memorized. What's tangent? Opposite over adjacent. So cotangent would be adjacent over opposite, which is negative root 3 over 3. Now, I think we got that answer to a previous problem. Or maybe it was a different period. Anyway, do you think you're going to get the same answers sometimes?
Yeah.
Yes, because after all, what are the only numbers you're using? 1, 2, root 3, and 1, 1, root 2. So of course you're going to be getting the same answers over and over again. All right, what happens on the next time I see you? And what will the quiz be over? Well, it'll be over.